Bonjour, bienvenue to Nick Does Maths. Je suis Nick. Voici Maths. Let's do some stuff. Something a little bit different today from the archives. We have a first order differential equation. dy dx minus 4y tan x equals 2y to the 1/2. Okay. We've got a first order. We've got a function of x here. So we could be thinking integrating factor, but there is one little snag. We've got this right-hand side here, 2y to the 1/2. So we're going to use a technique. We're going to transform our dependent variable, so not x, we're not going to change the independent variable, we're going to change the dependent variable. So we're going to go, instead of, we're going to make the change of variable z equals y to the 1/2. And that should give us this differential equation, which we can then use in integrating factors on. We will then proceed to solve for y. Let's see what happens. Let's make the transformation down here and then we'll solve up here. Right, so the first thing we want is we want to get from dy dx to dz dx. Well, dy dx is dy dz dx. Now dy dz tells me I should probably change this to get y is equal to z squared. Therefore dy dz is 2z. Do you know what? We'll probably finish that up here. I don't want to be too cramped. So there's it. We're largely there. Let's just take this and whack it in, and this. So dy dx becomes 2z dz by dx minus 4y, which is z squared, tan x equals 2z. And what am I able to do now? I can divide everything by 2z. So I am left with dz dx minus 2z tan x is equal to 1. Kabosho. Technical term that. And that's what we wanted. Lovely. Lovely jubbly. Now this is much nicer because I don't have that term in z anymore, that term in y. That no longer exists. So now we're down to, and I've got this first order one, a function of x, so what we need is my integrating factor is the exponential of the integral of minus 2 tan x dx. Now the integral of tan x, as a little aside, what is the integral of tan x? That is the integral of tan x dx is the integral of sine x over cos x, which is negative ln cos x, plus a constant, which we are largely going to ignore in all of this, because it all comes out in the wash. So, what does this become? This becomes the exponential of the minus and the minus cancel out, 2 ln cos x, and rules of exponentials, that becomes cos squared of x. So let's multiply the entirety of equation 2 by cos squared of x. I end up with cos squared x dz dx minus 2. Now cos x tan x becomes sine x cos x is equal to cos squared x. Now the right left-hand side now is a product rule. That is cos squared x times z. That's the whole point. And I know what's coming. I'm going to integrate any second now. So that tells me that instead of cos squared x, that is Wish I'd written that down first. Cos 2x plus 1 over 2. Cos 2x is 2 cos squared minus 1. Bosh, bosh. Yes, I think that works. So now I can integrate both sides. Cos 2x over 2 becomes sine 2x over 4 plus x over 2. Were we given any starting? No, we just want the general solution. So here's what we have. That seems about right. Now what we might want to do is change that sine 2x into a 2 sine x cos x. Because I'm about to divide everything by cos squared, I end up with z becomes tan x over 2. So I've got the 2 and the 4 cancel out to get the half. Sine x cos x divided by cos squared is sine x over cos x. So I get a tan x plus x over 2, and dividing by cos squared is multiplying by sec squared. But we're not done yet. We're still not done because we want it in terms of y. Z is y to the half. So what do I need to do? Oh, plus c. No, plus c is up here. I can't just whack that in wherever I want. So actually, plus c plus some constant times sec squared x, a little bit nicer there. So y is all of that squared. So my constant of integration is trapped all the way in there. Yeah, all right, does a thing, does a thing. So quite a neat little question, that one. We got this idea of transforming the independent variable, which I think is quite cute. Now, why would you know to do this? Probably because you've tried a load of other stuff and it didn't work. Which is a truth of maths. Quite often you get told to use something and you're like, well, why did you know to do that? It's like, well, I tried a lot of other stuff and it didn't work. If we get told it, it's because someone's realized the pattern and it does work. There are general things you can look out for to help you with this. Luckily, at further maths A level, we don't have to worry. They will tell us what to do. And it's all, the magic happens down here. The magic happens here, and then the cancellations happen, and we end up with something much, much nicer. Awesome sauce. Well, that was fun. I enjoyed it. Hope you did too. Do not forget to like, subscribe, hit the bell so that you don't miss these coming up. I think we're posting them every couple of days or so. Either way, let me know in the comments what else you would like me to do, what you'd like to see on the channel. I'll do my best to cater to what people ask for. Brain lag. Anyway, I'm Nick. I'll see you next time.